Till now we have discussed the three methods in transportation problem, that is northwest corner method, least cost method and Vogel's approximation method. So though we have solved the problem, we have arrived at some cost, but we are not sure whether that is the least possible cost of transportation, whether there is any possibility for improving the cost. That means by reducing the cost we will improve the solution. What we call that as test for optimality. Test for optimality will give us whether we have arrived at the most optimal solution or not. So for that we will apply a method known as Modi method, which is also known as modified distribution method. As per this method, what we will do is we will have number of rows and number of columns in the transportation problem table, where all the rows are represented by small u and all the columns are represented by small v. And then what we try to do is we try to conduct some test by which we call the test for optimality. What we try to do is, say first row will be designated by u1, second row by u2, third row by u3, fourth row by u4 and so on. And similarly first column is by v1, second column by v2, third column by v3 and so on. So what we try to do is we have already made allocation either by using least cost method or Vogel's approximation method or maybe northwest corner method. What we try to do is each cell is associated with some cost. We identify the cells where we have made allocation and say second row, third column. Second row is represented by u2, third column is represented by v3. Then we have an equation like this: delta ij is equal to Cij minus in the brackets u2 plus v3. So we try to identify the value of this. But before that, what we do is we try to identify, say let us say u2 v3 cell, the cell which is represented by second row and third column, let us say it has 20 as the cost. Then what we try to do is, if there is an allocation, u2 plus v3 is equal to 20. Similarly, there is third row, first column, we have made allocation. Third row is represented by u3, first column is represented by v1. u3 plus v1, there we have made allocation and the cost is, let us say, 18. Then we will write down 18. Likewise, for all the cells where we have made allocation, these equations are written. Then by arbitrarily assuming first value as 0, we will solve the values of u1, u2, u3, v1, v2, v3. Likewise, for whatever the number of u's and v's are there, we will find out the value. And then we will substitute in the earlier equation what we said, delta ij is equal to Cij minus so. So what we will do, this delta ij value is evaluated for unoccupied cells. We have written earlier values to evaluate uv values for allocated cells. Here we have identified unoccupied cells. What is our purpose here is whether by allocating or allotting units to unoccupied cells, whether we can improve the solution. For this, delta ij value is evaluated for all unoccupied cells in case if we get any negative values for any of those unoccupied cells, then it indicates us that there is a scope for improving the problem. But if we get zeros and all positive values for all the unoccupied cells, after evaluating delta ij, if we get zeros or positive values, that means we have already arrived at optimal solution. So if this way we are able to understand that which cell can improve the solution. Anywhere if we have got negative value, that indicates we can make allocation to that cell by moving some units from the cells which is already allocated, then we'll make those kind of adjustments and try to arrive at most optimal solution. But when we look at all these kinds of methods, northwest corner method appears to be very crude. It is not a scientific method, and usually we get highest cost by applying northwest corner method. But most of the times, least cost method and Vogel's approximation method will give us the lowest cost. 95% of the times, both of the costs will coincide. Very rarely, Vogel's approximation method may give us better solution, or least cost method may give us better solution. However, applying Modi method will enable us to know whether we have already reached optimality or whether we have obtained the optimum solution or not. Now we'll check with the modified distribution method. It is a check for optimality. This method, as we have discussed earlier, we call this as modified distribution method. As the name itself indicates, whether we can change or modify the allocation or distribution of the units among the various cells. We also call this as modified distribution method or MODI method. And we'll take the same solution which we have got in Vogel's approximation method. Since it is a test for optimality, what we do is we'll take the solution which we have obtained, which we have got lowest cost, and now we try to check for optimality. What check for optimality indicates is whether we can still further reduce the cost or not. So using this method, we will come to know whether we can further reduce or not. If we have already arrived at optimal solution, then that will be the final solution. If at all we haven't arrived at optimal solution, that means we may have to further improve the solution. We'll check whether the same problem which we have taken are solved through Vogel's approximation method. The same allocation will take and check for optimality. So while checking for optimality, what we'll do is we'll identify the cells where we have made allocation and assume that some hypothetical variables known as u and v, where ui plus vj is equal to the total cost, the cost of that cell for transportation of 1 unit. We'll see that however, after writing down those equations for the occupied cells, we'll evaluate those values of u and v. That means the first row, for first row is indicated by u1, second row is indicated by u2, third row is indicated by u3, and fourth, and when it comes to columns, first column is indicated by v1, second column by v2, third column by v3, fourth column by v4. So using those u1, u2, u3, v1, v2, v3, v4, we'll write those equations, evaluate the values for U1, U2, U3, U4, U3 and V1, V2, V3, V4. Now we'll make the same table, same cost we are taking, and then we'll write down those equations after filling this table with the same allocation which we have got through Vogel's approximation method. Then after evaluating, we have to find out the values are checked for optimality for unoccupied cells. In here 80, here 25, 5, here 30. So this is the allocation for these demands. Anyhow, this is a solved problem. We are taking the same values and we check for optimality.